Are on.
We're on.
Yes.
Okay. Good. Welcome, folks. We will not spend too long doing introduction-y things because there's a lot to get through.
Yes.
On Monday evening, Mads and I were talking in Copenhagen, and we talked for 3.5 hours. There was a bit of a break in there. We don't have 3.5 hours today, and we're still trying to cover pretty much the same set of features and things.
Yeah,
so,
pretty much. Yeah.
There's a lot to tell, and we're not going to even scratch the surface of C# 8, really. Because for one thing, there's a lot that I don't really know yet about what's going to happen. We're going to focus on the bits of C# 8 that are previewable, which means you can get it right now, although I wouldn't suggest downloading it over conference Wi-Fi.
Probably not.
But very, very briefly, I'm Jon Skeet. I'm a C# developer in Google Cloud Platform. There are other Google Cloud Platform speakers. Go see awesome things. Mads, do you want to introduce yourself?
I'm Mads Torgersen. I gave the keynote this morning. They introduced me there. And I also don't have a slide with other Microsoft people doing talks. So this is highly asymmetrical. My
laptop.
And I'm already miffed, but there are many, and you should go see them all. But I'm the lead designer of C#, and I have been really burning to talk about C# all morning, and now I finally get to. So let's go.
Woohoo! Cool. So I have various demos. The demo bits for both nullable reference types and for patterns are the same demos that you will see if you watch Dustin and Mads do their build talk. But given that it's me and Mads rather than Dustin and Mads, we'll probably have a different kink on things, and in particular, I've got another solution which shows what happened when I tried to use nullable reference types and some of the weirdnesses that I found. So, I get to rag on Mads a bit on stage live. It's great. But he's used to that by now. So
it's been a whole week of that.
Yeah. We apologize, by the way, for people who are near the front on the sides. We will try to explain what we're doing so that if you can't see the screen, you'll still have some kind of idea. Is this big enough, by the way, font-wise? Does anyone need it to be bigger? Yeah, OK, I'm getting thumbs up from the back. So we will try to explain it audibly. Mads will do interpretive dance of nullable reference types. And through the mixed media, hopefully we'll get the ideas flowing. So, Mads, do you want to give the big picture?
What are we doing? I cleverly set it up a little in the keynote this morning. If you were on the side that could hear, I hear that there were problems with the sound on one side of the stage.
Oh.
Essentially, yes, null reference exceptions are usually not popular. Sometimes there's a show of hands, like how many people love null reference exceptions? And there's always a few. And that's how you know who to avoid in the hallway after. But generally, having the null reference exception is not fun, because then you have to chase down where it came from and why you have it and who's to blame. And it's not that nulls are bad. It's just that you want to really say when to use them and when not to.
Right.
So the whole idea is that we want to retrofit a notion onto C# about when it's a good idea to have nulls and when it's not a good idea, and then we want to enforce it.
And in fact, that idea of there are things that are sometimes good, sometimes bad, and we just want to let people be able to express their ideas. That's sort of true of all of programming language features. It's all about you have your ideas, how can we make you express them where you couldn't before, or express them more concisely? And if you start looking at every new language feature and, right, what is that letting me express better or express that I couldn't express before, things start to fall into place a bit more.
Yep.
Let's get to a demo. So we have a really simple class. It has first name, middle name, last name. Somewhat sort of Western-centric here, but leaving that aside. So these are all strings. We have two constructors. One takes just the first name and the last name and leaves the middle name property unspecified here. We don't initialize it explicitly. And so behind the scenes, we know that means it'll be null. And then we try to use this. So if we try to do this with me, I would use Mads, but I don't know his middle name. And I probably wouldn't be able to spell it if you told me.
Yes, because I don't know. I don't actually have one.
Oh, right. Oh, wow. OK, we should have used
I will call you Leslie from now on.
So we can I'll just call the method rather than using the results. So we can get my middle name, and in fact, I can just write it. And if we execute this code, this bit's going to be fine, because we've got this getLength of middle name method that just returns p.middlename.length. So we're dotting into things. And that will be fine for me, and it will return 6, and it'll print 6. And then we talk about Miguel de Casa. Now, this demo isn't meant to imply that wherever Miguel goes, there are problems, and he causes trouble and things. That's just a corollary. But as soon as we do try to use Miguel as an example, we will get a null reference exception. This is expected. Now, this is the slight problem. So I've got 2 different versions of Visual. Well, I've got 3 different versions of Visual Studio effectively installed in different hives with different vsixes and things. So it can take a little while. But hopefully you can all see we get the NRE that you would expect. So the whole point of this feature is to try to avoid that. How can we find out that that was going to happen without having to run the code?
Right. I think that one important thing here is that if you look at this little tiny example, you know that it's wrong, but you can't really point to one line of code and say, that's the code, that's the line that's wrong. It all depends, right? Was it supposed to be null? Was it supposed to have checked? It's not clear.
Yes.
And
because we can't express
the expressiveness isn't there. Yeah.
Now, unfortunately for a tool, if Visual Studio is going to give us an error, then it does have to pin down, where is something going to be wrong? And it has chosen, in this case, the constructor. So this is using the C#8 preview, and that's assuming that any time you refer to a reference type in its normal form, that should always be non-null. At least by the time we exit the constructor, all the properties and fields should be non-null. And if we have parameter of string, that should be non-null, et cetera, et cetera.
Right. So to interject something here, we are changing the meaning of reference types in C# and a little bit.
Which is quite scary.
Which is a little scary, and which is part of the reason why we haven't gone near this feature for the decade that it's been discussed.
Have you thought of maybe making integer literals hex by default or something? As well?
Yeah,
just,
well, so that would be a big breaking change.
Right.
But the reason we chose to do it like that is that we don't want to just do it with all new syntax where everything works the way it used to, because the whole point of the feature is to point out places where your code is vulnerable, and your existing code is probably vulnerable in a lot of places, and we want the feature to be useful to find those places as well, and go and put annotations and null checks in until you're good. So it has to work on existing code, but it is only warnings, and it is the first language feature in C# that has an opt-in flag.
Right.
So you'll be able to say, don't give me those warnings, I'm not ready to deal with it, or I think your whole nullable thing is stupid. You get to not do it.
Right.
So
and that not doing is quite subtle, and the details are yet to be fleshed out of exactly...
Yeah, if you use a prototype, it always does it,
right.
because we weren't prototyping the user experience of how to turn it off.
Yes.
But we will at some point.
Yeah, and it's complicated because you may be writing a library and you're starting to experiment with it, but maybe you're not ready to say, this is null safe, this is sort of fully baked, right. Or maybe you are ready to say that because you believe everything's right, but you haven't yet actually fixed up everything right. internally. Or you may be consuming that library. So there are all kinds of different use cases.
There are hard parts that we're still working on. But actually, let's show the feature.
Let's show, yeah, absolutely.
And then we can talk about the things that aren't there yet.
So let's try, if you try to apply the feature to your existing code, it is like playing whack-a-mole. And so we will play whack-a-mole in front of you right now. Mm-hmm. So it's saying it's uninitialized. So let's initialize it. Let's, stupid Visual Studio doesn't know that things are going to be null. Okay. I've moved the error. It is now initialized, but it's initialized to something that it's not meant to be. So just to read the warning out to you, it's saying cannot convert null literal to non-nullable reference or unconstrained type parameter, which is C# speckies for you're getting it wrong. So what are we trying to express here, Mads? Something's wrong, but yes. What's wrong?
So the thing about assuming that reference types as they are today no longer can have null is that we also need to let you express when they can have null. And so that's where there's new syntax, or rather existing syntax that you can apply new places, because we now have nullable reference types. And that is why that is what the feature is called. We call it nullable reference types.
Because that's what's new.
That's the bit that has new syntax.
Yeah. So we want to make the middle name nullable because we're saying, if we're only saying you can provide two things in this constructor, we could make it default to an empty string, and that's one way of getting everything out. And that may be a choice that you would make in this particular case. Yeah. That's an entirely reasonable choice, and the compiler can't possibly tell whether that's the right choice for you or making it nullable. It would be a really boring demo if we just left it here and said, okay, so we're not actually going to show you any nullable reference types. Yeah, so we'll take the opposite approach.
Yeah, so the whole point is that you get to choose, but this forces you to think about, what is my design here? What should I do when there's no middle name? Yep. It makes you make a deliberate decision and stick to it, rather than just have whatever happened to be there when you went home for the day.
Right. And this is how you make that decision. It's a single character change. We're making middle name a nullable string property.
Right.
So whenever you if you call person.firstname, the compiler has said, if you have fixed everything up, and it's not a firm guarantee. It's not like a guarantee of, if you fetch this, it definitely won't return you something that isn't a string. It's not going to return you a button or something. That's really fully baked into the CLR. It could return you null, but if everyone's behaved nicely, it won't.
Yeah.
Okay, so there's a certain amount of, this is a trust system, an honor system. Whereas middle name, it's saying, do you know what? You really need to be careful now because this could be null.
It's making a polite suggestion to whoever's consuming it that they better be careful.
Right. And that polite suggestion has indeed gone. We fixed the initialization error, right. And we have a different problem somewhere else.
So now the consumer of this API, they get presented with a different public surface area, and these question marks, travel with signatures across assembly boundaries. And now we see the question mark on this side, or the compiler does, and it says
possible dereference of a null reference. Mm-hmm. This time, not so much you're doing it wrong as you might be doing it wrong. This is a bit of danger. So note that it's not saying that P might be null, because P here is a value of type person, non-nullable person. It's saying that, in fact, it's the squiggle is in slightly the wrong place. It should be on this dot that isn't covered by the squiggle.
Yes. I think you're probably right.
That's the bit that's potentially wrong.
But it's not all kinds of dereferencing that have syntax we can put squiggles on.
Absolutely.
So I think we're trying to be consistent here.
Yeah. So this is the thing that's might be
my excuse.
That we're then dereferencing.
All right.
So what can we do about that? We can, what do we want to return if someone has no middle name?
What do you think? What if you don't have a middle name? What's the length?
Zero? Okay, we can do that. So we'll use the null conditional operator, which works just as well as it always has. And so the value of this expression, the static type of this expression is now nullable int, and we can just use null coalescing operator, and woohoo!
Or of course we could have changed the signature of the method and propagated it back. But let's stop here. Yep. Yeah.
So now when we run it, we should no longer get the exception 6, which was from my middle name, and then 0 for Miguel.
So the thing to realize here is you didn't have to do a new kind of thing to convince the compiler that there wasn't a null here. So unlike many systems that have sort of null resilience built in from the start, they can just have, the only way you can check for null in those systems and get a value, the only way you can get a value out is if you check for null first. Like, it's sort of built in, whether it's done with pattern matching or something similar. By construction, you can't dereference until you've ruled out the possibility that there's a null. You can only dereference into a body of code where it's known not to be null. And we could do that in C#. In fact, pattern matching will do that for you in C#, but we don't want to force you to write your code a new way. The whole point of this is finding out whether your existing code is good and helping you fix it in the ways you've always fixed it. And there are about 1 million, or maybe 12, thereabouts, different ways you're checking for null today or making sure something's not null. And we try to recognize all of those by doing a flow analysis on the body of the code that is using the nullable references.
Which brings up an interesting point about it's not as simple as it sounds like it might be. So let's try to extract this. This expression is far too long. Let's try to extract some locals. So if we do string middle equals p.middle name, that should give us a warning because hey, that's nullable and this is non-nullable. So we can say, okay, we've got a nullable local variable, and then we can say, shall I use the old school syntax,
Sure.
and you can show new school syntax.
Sure, go for it.
So if we use this, we can return return 0 there. Now, what should happen if I do middle.length as after this check? If this were a simple feature that the compiler thought, okay, well, the type of middle is still nullable string, therefore, anytime you dot into it, we need to warn you, then this would not compile. But that would be less useful. It would give you a warning, and that would be less useful. So effectively, the fact that you can see there are no squiggles here, the compiler keeps for each, is it just for local variables?
No, it's for local variables and dotted names as well.
Right, okay.
If you had done it directly with p.middle name instead of having a local,
let's do that.
That would still work. Essentially, whichever way you do it,
right,
up to a certain point. Like we track, essentially, the flow analysis tracks current nullability for a given point in code for any given variable that is either a simple or a dotted name.
Right.
Of course, it does it more efficiently than that, but that's essentially it.
Yep.
And so
there's danger here, just to highlight that. Suppose your middle name property, either someone was messing with it in a different thread, or it was a bizarre property, like datetime.now is a bizarre property because it changes value all the time. Maybe p.middle name uses datetime.now and says if the second of the minute is 0, it will return you null. Otherwise, it will return you something non-null. Then you could easily still get a null reference exception here.
Right.
The idea is to protect you from the 80% of bugs, or probably more like 90.
So this is one of many ways in which the null warning system isn't precise and can't be, and we just have to live with that. But it's still, we hope, it's still pretty good. And a large part of it is not so much about does it catch everything. It's about making you make those deliberate decisions and having the expressiveness around it. Then the rest usually falls out pretty well.
Yeah.
Except for some corner cases.
It's probably the best example I've seen of the C# team being pragmatic rather than dogmatic. So we've seen that in other places as well.
I'm glad you didn't say first.
No, definitely not. So another example would be async and await. That async methods in C#5 always return task or task of T or void. It's like, well, that's not as general as it could be. Yeah, but do you know what? It does the job. And okay, it's generalized more in C#7 in a way that most people won't use other than using value task. But we did pretty well for a long time since, 2013?
Something like that, yeah.
Yeah, and when you were saying about 1968 versus 1967 for Simula, it's like Visual Studio year numbers aren't always necessarily the same as calendars. So you're building from the best, I guess.
Yeah. I that's one of the main lessons we took from the whole thing.
Okay, so we have been 20 minutes. We've got few minutes. Are there any other points about nullability that you particularly want to hit?
I think you had one that you wanted to get into, right?
Right. So there's one interesting idea here in terms of, is it reference equality? Yeah. So I demonstrated before that if you check whether something is null, if text is null, then the compiler knows after that text.length is fine. But this is just one way of checking whether it's null. Another would be to use reference equals text null, and suddenly we get squiggles.
Yes, because the compiler doesn't know that reference equals checks for equality.
And
because
another
it's just a method call.
Exactly. And another example would be if string dot is null or empty text. So if string dot is null or empty returns true, then it might be null. Yeah, this should be might be. But if it returns false, then it definitely isn't. And I was concerned until Monday evening that either we'd end up with situations where we would know that something was non-null, but we would have to tell the compiler we knew better than that, better than it did, which is like, that's what a cast always is. It's saying, I know more than you do, and every time you do that, that's a source of potential for you being wrong. So I want to avoid that as far as possible. We do have that.
Yes, we do.
With syntax,
It's a good opportunity to show it.
I don't know. I would really like it if this stayed officially as the damn it operator. My guess is you're not going to be allowed to.
No, we are based in America. We can't call it that.
Oh, we can do that for ECMA though. ECMA's based in Europe, so yes, when we do the standardization,
that's true. The standard,
we can make
standard can call it the damn it operator.
Yeah. So text damn it. It's not null.
It's a postfix exclamation mark that says, whatever nullability warnings you were about to give here, compiler, don't give me those warnings because I know exactly what I'm doing. So we can also call it the I know what I'm doing operator. Right. This will be on my tombstone operator. But it has many names.
My favorite example of it when I was applying all of this to NodeTime was if you're calling a method that says it should accept a non-nullable reference, if you're writing a library, you should still be checking whether it's null or not, because someone might be using an old compiler or might be disabling things, etc. So you should still be checking. You should throw an argument null exception. And so NodeTime is a good citizen. It does so, and I wanted tests to check that. So how do you knowingly pass null and convince the compiler that it's okay? And you do something like console.writeline, null, damn it. This is really not null, or at least I want you to ignore the fact that it really is null. However...
But that's not the reason why you stopped being concerned Monday night.
Right. Going back to this. So my concern was that either we would end up having to use the dammit operator far more than we wanted to, or that the compiler would have built into it, this is what reference equals does, this is what string.isNull does, and those are different things. So string.isNull returns true or false, and that's part of it. Reference equals, it's only useful if you know that one side of it is null, because if it's just if reference equals x, y, then whether that returns true or false, you don't know whether x or y are null.
You know that they are the same degree of null.
Right. And there are other things. There are methods that if you pass in null, it will return null. If you pass in non-null, it will return non-null. So all the cast operators in link to XML, you can cast a null X element reference to string, and it will return string. It's sort of null propagating methods.
Plus, there are generic things as well, where you have some of the link operators like first.default that says in the method name, I don't care what your elements are, but I might return a null.
Right.
Right. So if you use that with a non-nullable element type, you can still get nulls. So, so the list is pretty long, but you can make an exhaustive list, I think, of the sort of 99% of special null behaviors that are out there for methods, and then you can create a little language in attributes. That's what we are currently working on, of attributes that you can put on methods to say this method has special null behavior. Either it returns a Boolean and that affects this particular parameter that you put your attribute on, or the whole method is an equality method, or things like that. So we can make that little language, and then you can use it, or we can use it in our libraries, and use that. The compiler can know about that language, which
not about the specific
not
methods.
about the specific method.
Because I'm not going to submit a pull request to Roslyn saying, please be aware of these NodeTime methods.
No, it seems
but
like
I still want the compiler to be aware of where I have special null handling. So I was very pleased to hear that there will be this little language.
That's a nil plan, but it's not in the prototype yet.
That's fine. That's fine. Cool. I said we should stop nullability at about 25 minutes. It is exactly, it's now 26 minutes.
Sorry.
So we should look at patterns.
Okay.
I have the other
build.
build.
Can I say something about patterns in the old code that you had there?
Yeah.
Did you close it?
I did close it, but I've probably got something similar in the other one.
It's just, you do the comparison here.
Right.
Actually, comparing to null with the equals is a bit of a smell, and you will have because you have the risk that somebody has overloaded the equality operator, and they actually do something other than you would expect them to. Usually, if it's a good override of the equality operator, it will still deal well with null, and you still get the right answer.
This one is using the string overload.
But you might be executing a lot of user code to get to that.
Yep.
So actually, since C# 7.0, this is a little trick. The way that at least I recommend, I don't know if they put it into the guidelines yet, checking for null, is to use the is operator, because the is operator now takes patterns, and one of the patterns is the constant pattern, and null is a constant. And so by using pattern matching here to check through the is keyword whether it's null, that goes another route that doesn't let you plug in user code. And indeed make sure that you are checking that the reference is null, not running through some custom stuff.
And this is actually one of the side benefits. There's another feature that's being discussed to be able to combine patterns. If this pattern or this pattern, which would be potentially with keywords of or and maybe not. And if we have that as well, then we can be almost like SQL now. You could have if something is not null. And
or
how
like
awesome
Visual
would
Basic.
that be? Anyway,
Yeah,
okay.
don't get carried away.
Patterns. So that's that one. So I'm down to one Visual Studio open. That's always good.
Okay, it's going faster and faster. You'll notice we're speaking faster as well as we're releasing processing cycles here. So, patterns. Yeah. Do you want to go or should I?
Should we show the person? Show the types involved first. So we have a person that's a base class with first name and last name. A professor is a person. Some students may disagree, but a professor is a person who also has a subject, and a student is a person
Some
who
professors
also
might disagree.
a student is a person who also has a professor, and they're all done simply. And I would point out there's a little pattern here that if you haven't seen before, it's lovely, where a constructor, if it's just assigning properties or fields, one neat way of doing it is to use a tuple on the right-hand side and deconstruction on the left-hand side. And Mads assures me that the compiler is smart enough to avoid creating the tuple. I need to verify this at some point. And what I particularly like about this is in the person class, we've got not only a constructor, but a deconstructor. And the deconstructor looks exactly the same as a constructor, but slightly reversed, which makes the whole name work really, really well. So
yeah, we did think about it a little bit.
A nice pattern.
So because actually initially when we added expression-bodied members, we didn't even add them for constructors because who has a constructor of only one statement? You typically have a number of assignments. But once we had deconstruction in there, all of a sudden this pattern became possible, and now it's a whole pattern. You may like it or you may not, but it's a whole pattern where you can initialize your whole object in one expression and then just make it an expression body, and there you go, off to the races. I love it too.
And it kind of, in terms of why you would do it, it's not because it saves you a couple of lines of code, but it does, when you look at that, all this constructor is doing is assigning to properties.
Yeah.
That's kind of all it can do because the only statement is an assignment statement.
Right.
So I like that.
But if you do anything other than pass parameters on the right-hand side, if you start having logic like, oh, that parameter multiplied by the other parameter or anything like that, then I wouldn't do it anymore because then one thing it does is it removes the assignee and the value from each other a little too much for there being anything fancy going on.
Yeah. The one exception I might make to that is calling a method that validates that something's not null.
Sure.
Yeah.
Okay.
But maybe, something simple to do with just the one value.
We've negotiated this one.
Combining values.
We got it. Yeah. Yeah.
Right, so we should talk about patterns.
Patterns, that's where it came from.
And this is the only useful method we're just calling. Yeah, we're just calling this method. We'll focus on this method.
Right. So there are two things we want to, there's several things we want to do with patterns, and we're sort of happy to take patterns a bit at a time from release to release once we know how the previous batch kind of played out. And the next round includes a few things. First of all, it's all hunky-dory. You have a slightly different example here. That's still fine.
Oh.
It's all hunky-dory that you have a... what's that?
It's the one Dustin gave me.
Is it?
Yeah, I think.
Anyway, so using switch statements can sometimes be a bit of a pain. It's actually not too bad here because you're calling return in all these places, and so you don't have to say break. And so it kind of saves you a line for every case. But imagine that you had a variable that you need to get the string into and do something else with after. Then you have to assign to the variable and then do the break, and it gets a little more cumbersome. But either way, we decided it's time to have a switch expression in C#. That's the same pretty much as a switch statement, except the syntax is nicer and it works with expressions. Okay, so we could instead of running the switch here, we could just return a switch expression, and then whatever gets chosen gets returned. So the way it looks is the syntax we're thinking of is sort of an infix notation, because that's more expression-y, where you say person switch and then curly braces, and then you have your cases inside of the switch, ended with a semicolon like usual. And now it's complaining a little bit that it can't figure out the type of this switch expression because there's nothing inside of it. So we need to put something inside of it. So let's start doing that. We can just take them from the top. We don't want to make you put the case keyword in there.
Because it's always going to be there. Why bother making you repeat something that's always going to be there?
The colons, there's so many things in expressions that have colons. We figured it would read a little nicer with the fat arrow, but we're willing to discuss it. We actually changed our minds like a couple of days before we shipped the prototype on that. So can change again, but that's what the condition part of it looks like. And then you just put, instead of a statement, you just put an expression on the right-hand side there. So we can take that. Did I do something bad? No.
Copying is apparently a very hard thing.
Yeah, it must be rough for it.
To do.
Is it formatting my clipboard?
Who knows?
Who knows? Anyway, so that's all that a case looks like, right? Pattern, fat arrow, expression, and then the comma separated because again feels more expression-y. And we can do the other ones single liners there, so we can say student s, fat arrow. At least you have the same keyboard as I do, so it's not so hard to
that's
type.
the wrong one.
Oh yeah, yeah, you're right.
And you've missed the T off student before it starts complaining at us too much.
I did as well. And I was just saying how nice it is that there's a keyboard I can actually use. But apparently not. Student.
And to step into the role of Dustin, there will be glorious refactorings that make all of this easy.
Yes.
Having done tens of these at least manually, it gets kind of frustrating.
Yeah. So again, just a prototype. For the person case, there's actually a when clause in the switch statement, but which is not part of the pattern, but which is part of the case.
Yep.
And those are also available in the expression syntax. So you can.
While Mads types, just that aspect of when is not part of the pattern. I've found it useful when I've been learning about patterns to separate out in my mind what patterns are available. So there are type matching patterns, we'll show you property matching patterns, there are constant patterns and var patterns. Is that it? What have I missed? No, that might be it. So there are kinds of patterns, and then there are the places you can apply them, which are if statements or Boolean conditions and switch statements and now switch expressions. And each of those may well vary, may well be augmented independently, but if you think of them as orthogonal things, then as soon as you've learned, there's a new kind of pattern, you know, I can apply it in these places. So just that's a learning trick.
Yep. So this switch statement was already being a bit modern also in that instead of having a default, it had a case underscore, which is the new discard pattern, and it's used elsewhere as well. And that indeed is the only way that you can provide a default clause. Yep. You don't get to say default in a switch expression. But so this is really just syntax. It reads nicer this way, at least I think so. but yeah, your mileage may vary. It's a bit of a, I mean, it's a bit of a big expression here with the long strings and so on, but not too bad. So switch expressions, that's one thing.
Can we get it all to compile by getting rid of this now?
Yeah, then we can take the unreachable code and.
Yep. So there we go, and I feel honor bound to then turn it into an expression body member. Just Mads isn't as keen on this as I am, but I wanted to do this every time when I watched the build thing. I was like, why didn't you turn it? Now it's just one expression. Why are you still using a return statement? This is just lovely, right? But okay. We haven't shown any new patterns. We were going to say about patterns.
Yes.
What's going on with that?
Well, the thing we're thinking for the next bit of pattern matching is that it'd be nice if you could have patterns go a little deeper, right? So we have these type patterns, and we could maybe make them smarter. We give a name to the thing we get when the type check is true, and then we just dot into this name for different things. We fish them out. What if we could, as part of the pattern, we could get at those? So that's what the two different kinds of recursive patterns, what they're for. So in the person pattern, let's start with the person. In the type pattern, you can put, for instance, what we call a property pattern. So that starts with a curly and ends with a curly. And inside, you can start talking about the properties of person, the fields and properties. Okay, so if I start typing, you see I get completion. I can talk about the first name and the last name. I'm interested in the last name here for my conditions. I can say last name, colon, and then apply now I can put a pattern. I can apply a pattern to the last name. For instance, I can apply the constant pattern and use the Campbell constant and put it there instead. And now I essentially took that when clause and made it obsolete because I'm just applying the pattern that checks for the exact value of the last name. I'm applying that directly. I don't know where that came from. There we go. So that's one way of doing it.
Right. And now
we could get the first name as well.
Yes, we could. Yep.
If we want to, just to go all out. You may or may not want to, but we say the first name. All we want with the first name is we want to grab it so we can use it later. And the grab it pattern is the var pattern, which always works.
Right, which is probably worth highlighting actually in this particular case. So
yeah.
So Maz is changing, instead of dotting into first name here, we can just use FN now. Now, if you're someone who has strong opinions about, I don't want to use var, I want to use string, it's worth understanding that in this particular case, changing var to string makes a difference.
Yes.
Because the var pattern always matches whatever the value is. The type pattern only matches for non-nullable reference types, at least. I don't know what would happen if you did string question mark in there. I mean, in this preview, it wouldn't work because they're separate builds.
I think we won't allow it.
Right, okay.
Because the nullable types are not supposed to have any semantic impact.
Right.
Anywhere. They only give you warnings or not.
Okay. So if we change this to string FN, then it won't match if the first name is null. Okay, so where you've trained your brain to say, I can change var to the type of the thing that I'm looking at any time, that's not the case for patterns.
Right.
Okay.
You can essentially say var is the nullable version of it. And
right.
Var will always accept and just give you, infer the type and give you the name for it.
Right. And now we don't need P.
Now you don't need P. So now you get to elide that because nobody's using it anymore. You don't have to give the whole thing a name. And actually, because the thing that comes in is typed as person, you can also elide the type to begin with. And it's still the type pattern, even though it now has none of the elements of the type pattern that the previous type pattern has.
Right.
It's just abbreviating different things.
And you don't have to. You can still put the person there if you find that more readable. I'm uncertain on this. I think it's one of those things that you need to use and find out.
Yeah. And I mean, this is an example that's designed to go a little overboard with these things.
Right.
But, So let's go overboard.
So I'll try it myself. So I haven't played with this nearly as much as Mads has, so I may well make some mistakes here.
Good.
But let's try doing exactly the same kind of thing with a student, but we want to be able to pattern match to get the last name instead. So I'm going to pattern match, and the only bit of the pattern that's really doing matching conditionally rather than grabbing is the student part. So we're not expecting to have anything in here that, in the property part, that won't match. So I can say var last, or ln to be consistent with what Mads has already done. And then the advisor, well, I guess there's one thing. If I do, what are we printing out? The advisor's last name.
Mm-hmm.
Okay, and make that a var.
Yeah.
ALN for advisor last name.
Yeah.
Yeah. Now I think this has actually changed the meaning slightly. Oh,
it was actually
it was the first name that we need.
That was what went wrong. You got the wrong name for the.
So this isn't quite a refactoring because we're avoiding a null reference exception here because this pattern won't match if the student doesn't have an advisor. Whereas previously it would have matched, and then the interpolated string.
The type pattern in all its forms never matches a null.
Right.
Which is actually, if I can can I do a little trick?
Of course.
So
the indentation's gone a bit wonky, which is almost certainly my fault somewhere.
It doesn't matter. You can handle it, right? Don't get dizzy and fall off the cliff here because it's very steep. But again, you're Norwegians, you know about steep cliffs. It's interesting that since the type pattern never matches null, you can actually use it as a match everything except null pattern. Well, of course, you could say, it's persons. You could say person P already before matched everything except null, and it was only because we had a condition on top of it that it didn't match everything. But with the new curlies and with you being able to make everything else optional and elided, you could actually say, we only want to say come back last year to somebody who is someone. So the curly, open curly, close curly is a special case, but all it means is if you're not null, I match. Right? It's saying, I'm checking you at the type that you're already at, so I elided the type, and I'm going to check for all these zero properties that the patterns on them match. Oh, they all did. So all now left to do is to see whether you're null or not. So
this presumably will now we'll get a warning somewhere because this isn't exhaustive.
So that gives me a chance to show that off. You see now there's a warning on the switch which says, hey, as far as we can see, this switch expression isn't exhaustive. It's not, there are certain values for which it wouldn't match anything. And that's a little worse in an expression than in a statement, because for a statement, it's fine to just things you don't do anything for. But for an expression, you want some kind of result. And actually...
And it's so bad to do this that it only gives you a squiggly as a warning, but then the compiler has an internal error and fails to emit valid IL. And my guess is that may change before.
No, that's how we punish you.
Right, okay.
So it checks actually for the username. It's only a warning because sometimes that's surprising to what people want.
Well, so that's going to stay as a warning?
I think
I had fully expected that would become an error.
I think so. Also, I think there might be cases where we can't tell. I mean, similar to null, there might be cases where but it doesn't know, or stuff like that. Because actually figuring out exhaustiveness is pretty exhausting.
So if it does, my personal plea here, this is back to like being on Monday night. So what I've done in loads of cases, I have this a lot of the time. So in Node time, I've got a zone interval or some zone mapping. So if you've got a local time, that might map to 0, 1, or 2 instants in time, depending on whether you're in a daylight saving transition one way or another, or just normal. And I have a switch statement that says, what's the count, 0, 1, or 2, and then I've got to have a default and throw new invalid operation exception.
Right.
If the compiler just inserts throw new invalid operation exception, unmatched switch pattern or whatever, then yay, I can delete more code.
Yes, and the idea is that it will throw an exception there.
Awesome.
So the runtime semantics of falling through to the end of a switch expression is that an exception gets thrown.
Right. Cool. If it could be invalid operation exception as well, just for me, that would be good.
Maybe. I don't know if we've decided which one yet. But makes sense that it's that one. So, but in order to silence this warning now, we could go and use the underscore now as a catch-all and say, sorry, you're no one.
This is null discrimination.
Yeah, it is. Let's put a comma there to make it happy. But just to make clear that it really only is null that didn't fall through yet after I used that curly trick, we can do it just for null and see that we still don't get the warning back. Like the compiler really knew when it got here, it could see that we dealt with everything except null. So it's being pretty smart about the exhaustiveness, but it took Nilg after several months to get it right. So
cool.
There we are. There's one more kind of recursive pattern.
Go for it. I was just thinking, wow, we covered patterns much quicker than we took over an hour to do this on Monday,
that's because we're not
lots
done
of
yet.
questions and things.
So one of the things you notice is that all of these types have deconstructors on them, which is a pretty new thing, which lets you plug into the deconstruction.
Yep.
Okay. I personally don't recommend that you do that everywhere, because if you do it just to get values out of your type, then member access is much better. But if your type really is sort of tuple-like, and you often want everything
and the ordering will be entirely clear to everyone reading your
the ordering
code.
makes sense. The ordering is part of it. Yeah. Can you really remember which order those three ints or those?
And if things are a different type, I guess. You know, if you've got the Go style of success or not and the result, so they're going to be a different type. And if you get them round in the wrong order, then your type system will complain at you anyway. Then that's probably not so bad.
But the danger and the allure of the positional approach, if you will, is that you have to remember the order, but then you don't have to say the names, and so you get to say things shorter. Shorter when in order. That's like a little... why don't we think of that also in terms of patterns? That dichotomy here, we're doing the property patterns in a name-based way. We say the name of that property, apply a pattern to it, and so forth. But maybe when we have deconstructors on the types, why can't we apply the deconstructors and do the patterns in order on what comes back from that deconstructor?
Right.
And indeed, we can. So let's do that for the last example up here, the professor, which, not surprisingly, we do the deconstruct pattern using parens. And we want the last name and the subject. And I seem to remember that professor's order was first name, last name, subject.
Okay.
So we can ignore the first name with the underscore, which you can't see because of the red squiggly. Then we can get the last name, and we can get the subject, for instance. Okay, something like this. And that is a very concise way of sucking out some values and using them later, which we didn't get to the using them later part. We will now. It makes it, nice and terse, but also just that little bit harder to maybe.
Yeah, and I'm going to just
you could use better variable names maybe.
Let me just check that I understand it properly, and this is genuine. This is not me sort of faking it. So that one just grabbed the values, but presumably we can use this in the same way as the property pattern, that sometimes we're grabbing, sometimes we're doing things conditionally.
Oh, yeah.
So I can do, and can I replace the whole of the property pattern with just this without specifying the type? So string fn and Campbell.
Yep.
So
you can, hang on, don't delete.
Right.
This works without you deleting anything because what you have to think about is that these patterns, the way that we decided on the syntax was as much analogy as possible to construction. When we're matching against something, it's like we're deconstructing it. We are conditionally deconstructing it. And therefore, if it looks the same as when you're constructing things, that's nice. When you construct an object, you say new, you have the type, which in a later release might become optional. You optionally have some constructor parameters, and then you optionally have an object initializer.
Yep.
And you can have all of those if you want to. And the same way in a type pattern, you can have both. If you really want to, you can have both of those patterns at the same time.
Discard there and discard here.
Yes.
And so this is the grabbing part.
You can you can't just discard.
Oh, sorry.
Just delete it.
So this is the grabbing part, and this is the matching part. Yeah, I don't think I'm going to be using that.
No, but it's just pointing out the generality of it.
Yeah,
Right.
Unless there are bits where deconstructing gives me some things, and there are some bits. So with the professor one, yeah, we have the deconstructor that gives you all three. But if we only had the two of them, then we could deconstruct to get the last name and things.
I don't think it's going to be common to use both. Not at least
but
not
the principle is a useful one.
It's just trying to make things as composable as possible.
Yeah, and that's sort of making the fact that it's commas here rather than semicolons, because that's how you express a sequence of things. So this is like a collection initializer for a switch. It's like, here are the patterns within the switch. It sort of takes a little while, but then you think, yeah, that is entirely natural.
So there's actually something you can do in, let's see, no, I can't, no, I don't have a good example of it here. Yeah, actually I do. There's something you can do in ordinary deconstruction for ordinary variable declarations and so on, which is that you can put you can sort of factor a var outside,
right?
And then you just have variable declarations inside. And you can also do that in patterns. I just can't remember if we implemented it yet for this prototype, but I think we can do this. Let's see if it works. Yes, but then you can't have the so it's a variant of the var pattern.
So this would now match if the first name is null, when it wouldn't have done before.
No. So it's a little inconsistent. Maybe we should allow it with the curly braces as well, actually. We'll have to discuss that.
Okay.
But you get to factor the var outside of the deconstructor thing if you don't also have to say a type there. But it's a little special casey.
This is a pleasure for you. Normally when I'm doing a talk and I talk very, very quickly and leave at least some people's minds going, I don't understand. And now you get to see exactly the same thing with me on stage.
Actually, me too.
I don't really understand.
Wonder if that works, but it sort of partly works. I can see.
Just in a couple of minutes, because I have something else to show as well.
Okay.
We should talk about the other features of C# 8 that might happen. Everything.
Right.
I guess you're pretty confident that these nullable and switch expressions and pattern matching extensions will happen.
Right, and there's one more feature that is also actually in prototype. It's in the same prototype, which is was that what you wanted to get to?
It wasn't.
Okay.
Yep.
Which is about indexes and ranges. So we want to make C# a little more expressive when it comes to talking about both indexing into data structures and also looking at windows, sort of subsections of things. So we want to support in the language expressing indices that are also from the end. Indices are normally integers, and also expressing ranges. One of the motivators for it is the span of t stuff that has already happened in the language. So I don't know. Do you want to go, or should I?
Yeah, go. Let's be reasonably speedy, but yeah. Just
quickly, well, it's really annoying sometimes when you want to look at the last thing and you have to do the arithmetic and make sure you're not off by one and so on. So we actually now have syntax for getting the last element. So I can just say hat1. And people who like regular expressions typically complain about a choice of hat, but it is...
because hat would normally mean the start?
Yeah.
Fantastic. Finally, I have a way of remembering, because I always get confused which is dollar and which is hat. And if I remember that it's the opposite of what C# does, then...
Well, it would be
You laugh, but that's how I'm going to remember it.
It would be even easier if we had the dollar sign. But you know what? This isn't set in stone, but that is what we went with for the prototype.
Yep.
So, and the nice thing about it, it's not like a part of the index or syntax or something like that. It's a completely independent thing. So I can, in fact, I wonder if this works. I can introduce a local for it. And it's even decently named.
And importantly, that's one off the end of whatever you apply it to. It's not sort of relative to text in this case.
Right. So
I could use
it's
the
a
same
notion
thing
of,
for multiple
of
things.
one from end that's independent of the length of the thing you eventually apply it to. And then we have a notion of ranges, which for substring, it would be really nice if we had an overload that took the... Actually, there's a bug here, right? It should have been set -2 for this program, because that, just to show how easily is to be off by 1. You want to chop off 1 at either end,
Yep.
but since you're saying the length of the result here, it should have been 2 shorter than the length of the original thing. But it would have been easier if there was an overload that took an index at the end there. But there isn't, but there's something even better, which is an overload that takes a range, so range expressions with ... between 2 indices, which can then either be an int or a hat int.
Right, and they're independent, so we could do range of 1 to 3,
Yes.
or we could do range of hat 3 to hat 1.
Yes.
Is the last, ignore the last character, but the 2 characters before it.
And of course, it's composable, so I can reuse that index that I have up there, and it still becomes from end. And there's a shorthand for leaving off on that end, and that means hat 0. That means the end, all the way to the end. And if you leave off in the beginning, that means 0.
Right.
So, and of course, combining ranges and indexes now really becomes nice, right? They're 2 independent features, but if you combine them, you get something that's very nice and looks like what other languages have. So you can imagine, and we kind of sort of hacked it up if you put the right source code behind, which I think you did, that in the prototype you can try it. We have an indexer on text that takes a range. Now you can substring just by applying an indexer and a range expression. So like this was, I think, was the original example.
Right.
Okay.
And that would work not just for strings, but then for any span and anything that implements it appropriately.
And probably arrays, we would return spans when you substring or when you slice those. It's essentially for slicing, right?
Cool.
So anyway,
I want to demo something slightly. So we've been talking about the future of C#, the language. 2 minutes. Yeah. The future of what's in the language. I want to point out a couple of things about the future of where you can use the language. So one of these Mads has seen and one he hasn't. So as you know, I write the NodeTime library, and it's been a source of frustration to me that the NodeTime website is very static. It's very, here's the stuff. So I've been working with the try.net team to embed a live coding environment in the NodeTime website, and today it somewhat works. Okay, so we have some things. I can say, right, get the current zone date time, and we have IntelliSense assuming that the network connection's working. Yeah, so I can find out what properties are in my zone date time, and I can run the code, and it's showing. Now you'll note it's showing the 10th of June because this is cached. Anytime that you run stuff with try.net, if it notices you've got the exact same source code as a previous execution, it'll return you that result. Now, earlier on, this wouldn't work. And it's possible that this has been fixed behind the scenes with my friends in the try.net team. It's also possible that it hasn't. And wow, I didn't expect it to complete. All right, there we go. Right, so I think this has given a 503 on the back end. It will be fixed. Oh, no, wow, it's worked. Thank you, Diego, or whoever it was that fixed it for me. So this was running live code, and the idea is I have some recipes here. You can find out how old I am, just copy that to the editor, edit it there. The web design part is nothing to do with the try.net team, which is why it's awful, because this is my web design skills are non-existent. But again, you can run the code, and it will say that it's nearly my 42nd birthday. So that is running C# in a cloud container somewhere, but you get to edit the C# code live in the browser. And the other, what I think is very cool way of running code, and this is taking more conference Wi-Fi than I would like, is running C# in the browser itself. So, for example, suppose we want to find out more information about the Copenhagen time zone. Because, no, in fact, let's do Oslo. Yeah, we're in the... I shouldn't travel so much. So, in Oslo, we can... And I'm very new to this. This is all something called Blazor. And this was hacked together over the last few days or so. And we've got all this stuff coming. This is not on a server. I could disconnect from the Wi-Fi and still do stuff. I can do this on my phone. This is running C# via WebAssembly, via Mono that is in JavaScript/WebAssembly, interpreting the IL from the NodeTime assembly. So when you think about the future of languages, don't just think in terms of the future features within the language, but where are you going to be able to run it next? And I'm sure, basically, any future language will be designed so it can run pretty much anywhere.
It's the old Microsoft logo, right? Where do you want to run today?
Right. Yeah, and so I think that's pretty awesome. And I wanted to, this is the very first time
cool.
of showing try.net on the Node Time website, which is something I've been excited about for a few months now. So that's all we have time for. We'll probably be around at the front packing up and things if you want to come and ask us questions. Thank you very much.
Thank you.
And what I should have said